Alright, this video tutorial is going to deal with how to calculate nozzle flow rates, or to calculate specifically the average nozzle flow rate on your boom spray rig, and then how to determine if it needs to be replaced or not. If you take a look at your calibration module, on page 5, there's a green block. On that green block, it says a nozzle that is flowing slower than the control nozzle will have a percentage lower than 100%. A nozzle that is flowing faster than the control nozzle will have a percentage that is over 100%. Keep in mind that as nozzles wear out, they will flow faster. Therefore, you'll not often find that nozzles are flowing slower than the control nozzle. Check for blockages if you find the control nozzle is flowing slower than the control. Alright, then a very important sentence there. We allow for a 10% variation between the control and the other nozzles. Alright, the example on that page gives us a control nozzle that is flowing at 1,61 liters per minute. Alright, then we've got 4 test nozzles, 1, 2, 3, and 4. Test nozzle 1 on the test did 1,64. Test nozzle 2 did 1,5. Test nozzle 3 did 1,65. And test nozzle 4 did 1,6. Alright, these are all liters per minute. So in other words, what this means is that when we did our test, we measured all these nozzles. That is the volume that each nozzle gave us, all right, in the test minute. Now, it's very important to obviously have set the spray rig correctly and to be working at the desired pressure. Otherwise, none of this is going to be relevant. But that, I'm not focusing on that now. We're just looking at the calculations in this tutorial. All right, we've seen that our control nozzle is flowing at 1.61 liters. That means that is the optimum for that nozzle. So everything should be pretty much the same as that. That's why we put it there. That becomes our benchmark, all right? Anything that's flowing faster means it'll have a higher value. More has flowed out through that nozzle in the minute. So for example, this nozzle is showing us has flowed more, and this nozzle has flowed more. This one and this one have flowed slightly less. All right, we'll take a look at all of that now. Alright, now on that page 5, it tells us that the first thing we need to do is to determine which nozzle has the greatest difference to the control nozzle. Alright, so how we would do that is a simple minus sum. Alright, you can take a look and see here. The one that seems to be the difference that's the biggest with regards to being more would be this one. And the one with the greatest difference being less would be this one. So let's do a quick minus sum to determine which is more and which is less and what sort of difference we're looking at. All right, 1,61 minus 1,5. All right, remember we can put a 0 here. All right, it doesn't change the value. If it helps you keep your places in check, then you can do that. All right, let's take a look. 0 from 1 is 1. 5 from 6, 1. Our comma has to stay in place there. 1 from 1 is 0. All right? So 0,11 difference between control nozzle and test nozzle number 2. All right? This was test nozzle 2. Let's take a look at the difference between the control nozzle and test nozzle 3. All right? We'll start with the biggest one. 1,65 minus 1,61. It's going to give us 1 from 5 is 4. 6 from 6 is 0. Our comma has to stay in place. 1 from 1 is 0. All right, this number is bigger than this number. All right, this would be the equivalent of saying 11 over 100. This would be the equivalent, let me write it here, that is 11 over 100. This is 4 over 100. All right, if you're not sure of how I got to that, take a look at the clip that I've done on decimals for you. All right, the first tutorial that I've uploaded is one on decimals. So if this doesn't make sense to you, go back to that one. All right, so now we've determined that the nozzle with the greatest difference to the control nozzle is nozzle number 2. Okay, now we can carry on to the next point. All right, if we take a look at the next page, page 6 in your module, I'm not going to go through all those steps by writing them down because that next lot of information is right in front of us here. We had to convert those to milliliters, all right, that's been done. And to see what the percentage difference that we have between the control nozzle and the other nozzle, we need to do the following sum. All right, so now this we are going to take a look at, okay? I see I did make a mistake here. I've referred to 1,600 instead of 1,610, all right? That was kindly pointed out to me during one of the contact sessions last week. So let's take a look at doing the sum correctly based on this formula, all right? All right, so here we've got our formula. We're going to take our test nozzle minus our control nozzle, all right? Our test nozzle was 1,61 liters, which is the same as 1,610 moles. And we're going to divide that by our control nozzle. Our control, hang on, I'm just going to go T here. Our control nozzle was, sorry, that was our control. Sorry, guys. That's our control nozzle. Our test nozzle is 1,5. So that becomes 1,500 moles. All right, so take a look at our formula. Over here, we're going to say test nozzle divided by control nozzle. So we're going to say 1,500 moles divided by 1,610 moles. This is where that mistake was in your module. And the answer on that is going to be 0,931677018, and it carries on and on and on from there. We're going to round this off, all right? We're going to round it down to three decimal spaces. So we're going to say it's 0,93. Let's take a look. 932. All right, let's double check that. Became a 2. 2 doesn't do anything to the 0. 0 doesn't do anything to the 7. 7 changes that to an 8. 8 changes that to a 7. 7 changes that to a 2. All right, so that's our answer at A. All right, at A. Now we're going to times that with 100 to decide what B is going to be. So that times 100 is going to equal 93,2. All right. And that's a percentage, because what we've done is we've worked out what percentage difference there is between our control nozzle and the test nozzle. Okay. Now, if you go back to your module, it'll tell you that a 10% difference is okay, which means that anything over 90% and under 110. So if this answer is between 90% and between 110%, then it's good to use. Okay, that's our range that we accept. Okay, it's got to be within 10% of the control. The control is 100%. So anything in this range and in that range is acceptable. 93.2 is in this range, so it is safe to use this nozzle.